Okay, so let's take a look at 5.6, the sine law. And if you remember the sine law looks like this: sine A over A equals sine B over B equals sine C over C. This is more appropriate for when you're looking for an angle. And this, which is the exact same sine law, except little a over sine A, little b over sine B, little c over sine C, this is more appropriate for when you're looking for side length. Side lengths obviously are indicated by lowercase letters, and capital letters indicate the angles. So when to use the sine law? Well, if you have a 90-degree triangle, you want to try to use the Pythagorean theorem or stick to using SOHCAHTOA, which is the trig ratios. But if you do not have a 90-degree triangle, you must use either the sine law or the cosine law. So when would you use the sine law when you have no 90-degree triangle? You would use the sine law when you have two angles and any side, or angle, side, angle. So two angles and any side. Or when you have two sides and an angle opposite one of those sides. Okay? So let's look at example 1 here. Example 1, it states, in triangle RST, angle S is 83 degrees, angle T is 26, and little r is 53 meters. Solve the triangle, route side lengths to the nearest tenth of a meter and angles to the nearest degree. So what I did was I just drew triangle RST. I just drew it as a triangle. It's not to scale, obviously. I labeled angle S as 83 degrees, angle T as 26 degrees, and little r, which is across from big R, as 53 meters. Then I am trying to figure out the two side lengths and also this other angle R. Angle R is very easy to find because I know all angles add up to 180. So angle R was found by taking 180, subtract the other two angles, and you'll get angle R is 71. Then to figure out little t and little s, I wrote the sine law, little t over sine t, little s over sine s, and little r over sine r. Filled in the blanks. I knew that big T was 26, big S was 83, little r was 53, and big R was 71. Then I split this up into two different questions because I understand that I have to keep this fraction because I know both top and bottom. So first what I did was, these are all equal. I made 53 over sine 71 equal to T over sine 26. Then all I did was cross multiply this sine 26, so I had 53 sine 26 all over sine 71. And when I do that using my calculator, I got T equals 24.6 when I round. And similarly, I went to go find S using the 53 over 71. So I wrote 53 over sine 71 is equal to S over sine 83. That comes from right over here. So then all I did was cross multiply the sine of 83. So 53 sine 83 all over sine 71, I ended up with 55.6, and that is what S is equal to. Let's continue this. It says here, only in a case when two sides and two non-included angles of a triangle are given, the triangle may not be unique. It is possible that there is no triangle, one triangle, or two triangles that exist with those given measurements. So let's see what that means. So example 2, what I did here, it says solve the following triangle for GHI. Angle G they give me as 30. Little g they give me as 11 centimeters. And little h they give me as 20 centimeters. So I drew a triangle here, not according to scale, but I called this GHI. I labeled this as 30, this is 11 centimeters, and this is 20 centimeters. And then I went to go solve. So what am I solving for here first? Well, I am given two side lengths and an angle that's opposite one of those side lengths. So the first thing I went to go find was angle H. I set it up as sine of big G all over little g is equal to sine of big H all over little h. So I did sine of 30 all over 11 is equal to sine of h, which I didn't know, all over 20. Then I go to solve for h. I cross multiply the 20. So I end up with 20 sine 30 all over 11 is equal to sine h. 20 sine of 30 I did on my calculator was just equal to 10. So I get sine h is equal to 10 over 11. So we got to remember the cast rule, because the cast rule states that sine of h is a positive number in quadrant 1 and in quadrant 2. So we all know that there could be acute angles in a triangle, okay? But there can also be obtuse angles in a triangle. So we have to remember this. So when I go to solve for h, I bring sine to the other side, sine inverse of 11 over 10, and I get h is equal to 65.4. So I got the one answer in quadrant 1. I also have to remember there's an answer in quadrant 2. How do I come up with that answer? Well, if I do 180 minus 65.4, I end up with 114.6. And that is another possible drawing for this triangle. This triangle could have been constructed like this, where G is 30, H is 114.6, and those other measurements are the same. And I'm going to let you continue this, because now, for this triangle that can be constructed, you can find big I. After find big I, you can find little I. And for this triangle number 2 that can be constructed, you can find big I, and then you can find little I as well. So you end up with 2 triangles when given these measurements. If we take a look at the example on the back, you're going to see that example 3a, it asks us how many triangles this can be constructed. Well, number A is exactly what we just did, and you can clearly see that 2 triangles can be constructed there. But in question B, it said in triangle XYZ, big X is 35 degrees, little x is 5 centimeters, and little y is 3 centimeters. So I drew a triangle here, and I drew that little x was 35